hangman's almost over, yeah.
Yeah.
Wait,
So-
which one?
So the key thing, the first problem, the key thing was the 9-point circle has the center halfway between H and O, yeah.
Yeah.
So that's equal, yeah.
Okay.
I still use black. Maybe I'll use red.
Wait.
So
is
H
this-
is the orthocenter, O is the circumcenter, and P are diametrically opposite, yeah. Okay, so we know from previously that the 9-point circle center is in between, yeah.
Yeah.
And it's also got radius half OP, yeah.
You prove that one.
half
Yeah.
OP, yeah.
That's the radius, yeah. So can you see, like, and we also know by this theorem that Simpson's line bisects pH, yeah. So they go through these points. Right? So if you connect them up, yeah.
Wait, the Simpson line. Oh yeah. Oh
So-
yeah, it bisects it.
So bisects it, right? So so can you see that that means that
That's a straight line.
this is also a straight line as well. They're both parallel to the
Yeah.
diameter, yeah. But also
That's
this is half the length of
Yeah.
that, yeah. So it's actually on the circle,
Yep.
right?
Mm.
On the 9-point circle,
Oh.
because that's the center. That's half the radius. Yeah.
Half the radius.
Okay.
So the 9-point circle has radius half the radius of the big circle.
Oh yeah.
So that means these 2 points where the Simpson lines intersect are on the circle, right?
Yeah.
And then somewhere along the line, they meet at 90 degrees, yeah?
Oh, then it's on this. Right.
Then it's
on
the
this-
so this is the diameter.
Yeah.
That's 90 degrees, so it's on the circle.
Yeah. Wow. Okay. Yeah.
Does that make sense?
Hmm. Oh.
Yeah.
Yeah, maybe we can come back to this after we do the next question. So,
The next question is like not math, but like
yeah, I guess that there's some things we should be a little bit more careful about. I don't know if it's... Yeah, that's the weird thing. Like, logically, they're important. On the big scale, they might not be that important, but I think it's important to be aware of it, yeah?
what?
Because it says let P be any point on the circle, so,
So it
right?
could be like the
Vertices.
Yeah.
So that doesn't make sense anymore, right?
Wait, wasn't there like some question where you had the Simpsons line?
Well, if it was the vertices, right? Then
Then
the
it wouldn't be
Simpson
a
line
Simpson
would just be
line.
the altitude, right?
Right. Yeah.
So it can't bisect itself.
Yeah.
You know, like it's on the line that is meant to bisect. That's a problem, right?
Yeah.
So it can't actually be any point, I don't think. But otherwise, yeah, then the O is the same as H, right?
Yeah.
Yeah. So something generic is
Oh,
implied.
P can't be.
That's the vertices.
P can't be also diametrically opposite.
The vertices. Because then one of the edges is the Simpson line.
Oh wait, actually.
And the edges bisect.
Should be fine.
Oh no, it should be fine.
Yeah, it should be fine. It shouldn't make a difference. As long as it's not the 3 vertices, it's fine.
Yeah, then I guess what happens when H equals O, right? Then this is a problem too, isn't it?
Yeah.
Yeah, this is not in the book, but I think we should think about it.
N
N would just be equal to O,
Yeah,
wouldn't it?
Yeah.
But then it'd be hard to conclude some midpoint stuff.
Oh no, then it's just actually the midpoint. Yeah. It's just the midpoint of the diameter.
Oh, okay, then it works.
Yeah.
Okay, because then...
And then P equal HP dash whatever. Yeah. HP prime B equals HP would be. So just be half. Yeah.
Okay, so it still works.
Yeah. It's like a general case. I know it's a more simple case. Yeah.
does it work if P is one of the vertices?
No. Where?
The first one.
Oh. What if one of the vertices is the diameter? Or the edges has its diameter? I mean, it'd still be true, I guess.
Wait, the function.
Yeah, it'd be true.
See, the thing is, like, if we didn't see that the second one had these problems, we wouldn't even think about it so much at first.
P is A or something. Then we're like, overview like the same.
Yeah, so I guess the second one's still true if you say passes through the midpoint of OP, yeah? That would still be true.
Yeah.
Okay, cool. That's the